What we're going to do is practice writing some decay equations. This lesson has lots of theory that you need to read through and try to understand as much as possible. You really need to know a lot about why things become radioactive, which I state in the notes. Too many protons or having basically isolated protons and neutrons will cause decay. This is the reason why certain elements tend to be radioactive. You need to know the different types of radiation, or radioactive decay, alpha, beta, gamma. You need to be able to write their equations. You need to be able to explain penetrating depth. You need to explain what the particles of alpha, beta are, and you need to be able to write a decay series. So we're going to do a few examples of each one. This one's using your periodic table of elements, which is part of your formula sheet. Finally using that last one, so you need to have that handy when you do these. What we're looking at here is iridium 168. So iridium 168 is going through alpha decay. So iridium is IR. It's element number 77 on the periodic table. So I know how many protons it has, and it's 168 is the total number of nucleons. It's going to undergo alpha decay, so we know an alpha particle is a 4,2, and now we have to balance total number of nucleons, and then we have to balance charge on the bottom. We always have to go through conservation of charge, conservation of nucleons. So when I look at the top number, I have 168 total before. I have to have 168 after, which leaves me with 164. 77 before. I need 77 after, so that means I have to have 75. And when I look at element 75 on the periodic table, it's rhenium. Re. That's how we do alpha decay, or any type of decay. First of all, you figure out is what type of decay it goes through, write the particle, then balance the nuclear equation. Total charge, total nucleons have to be same before and after.